We are here to talk about best practices for on-set wireless. Let me tell you about what we're going to do tonight. The agenda will be that there'll be a presentation by my friend Enrique Del Rio. He's a cinematographer. He specializes in high speed. He's also an equipment owner, and he has a background as a DIT. And he owns some wireless systems. He got very frustrated because he was always getting these complaints that there was malfunctions, but almost all the time it was operator error, when he started to look into it. So he thought, how can we teach people, to have the best practices, and so to make my life easier so I wouldn't get all these complaints. And so he went and conducted some interviews with the fellows up there, and that would include Nicol Verheem. He's Teradek founder and the CEO of Creative Solutions, which includes not only Teradek, but Paralinx and SmallHD and Wooden Camera and et cetera, et cetera. Also, Manolo Rojas, SOC. He's co-founder of ChilipepperLabs, and Dream is their product. We also talked to, or I should say, Enrique interviewed Greg Johnson, who goes by the nickname of Noodles. Noodles is president of RF Film, and what they do is they service very large productions, major motion pictures like Fast and Furious is one of their clients, and all the big ones, especially when they have aerial photography, because that's very specialized. So he just comes and handles all the wireless for these movies. And then, of course, we have Greg Smokler, who's not only appears in the video interviews, but he's here tonight. Greg's the founder of Paralinx and VP of products for Creative Solutions, which include brands such as Teradek, Paralinx, SmallHD, Wooden Camera, and I think there's even more. So I'm going to turn it over to Enrique now. I'm going to sit down, and I'll just operate the PowerPoint.
Thank you, James. Hi, everyone. Thanks for coming. After what he explained, I realized that one of a horrible thing to hear on set is that Crafty ran out of coffee or gum, as we all know. But the really, really awful thing to hear is an angry voice from Video Village that would say, "There's no picture." And I'm hoping a lot of you come from camera. It's a very frustrating thing, and that's when Poker Face and has to take command, but with an underlayment of panic. So it's how do we fix everything? I see some young faces, but some other people who might have been in the industry for a while. I'm assuming everybody's familiar with the word modulus, 180-degree shutter, or even 5296. What that is? Anybody doesn't? Okay. So going back to how we got to this point in wireless transmission. It all started with the need to cut the umbilical cord from the camera, right? So the cameras finally had video assist. That video assist had a very simple, very simple transmitter who was a single channel. That's all it did. It transmitted in UHF. It would stick the antenna and power it, feed the video, and you were off to the races. Kind of races. It was black and white, and it was horrible. Then we had the modulus. The modulus started with the 2000. It was it would get hot very fast. Then they did the 3000. That had a heat sink, and that helped a lot. Then they did the 5000. And then shortly they got banned because they were illegal. Anyways, cut to nowadays when there's so many systems out there. Before you knew, and even now, you don't want to leave a rental house with whether it's a mat box, a head, follow focus. There's the de facto things that you have to have. Well, now, and thanks to companies like Paralinx, now it's part of the package. But now there is so many of them that the traffic that you get on set it's even worse than, I don't know, the 405 on Friday on a rainy day at 5 o'clock. So it's that bad. So we needed to have an idea what happens. And trust me, when I started doing the research and all the things that I found out, it was like, wow, you are limited on how many channels you can work on set. And this is something I will stress over and over again, because it was really an eye-opener, and how careful we have to be on set so we don't hear that scream from Video Village. Because as you know, if you've ever been an assistant, and there it's really bad. So we have in the interviews a nice explanation from their point of view of how we got to this point.
Wireless video on set has evolved from the days of film where pretty much only SteadiCams would have a UHF transmitter system, to now where nearly every single camera package goes out with a zero delay wireless video system.
Guys had modulus, and that was the tool. And it worked on low frequency television modulation, and it was just garbage. But all analog, line of sight, if it went around a corner, it was gone. The film camera started fading away, and all of a sudden now we have to go to HD. Well, holy crap, high definition. Well, that's a whole other, that's a whole other thing. There's not a lot of people making encoders yet, and very sketchy.
With the first HD cameras, it's not that big deal because we don't have, in that time, HD monitors on set, or not so many monitors, so nobody was asking for HD signal. But, so it was really easy, just converters, down converters, like the typical decimator, the most used converter here. And then we just take standard definition signal, analog, and plug into the modulus and transmit it, and that's it. But then the HD monitors became really popular, and the people start asking for HD monitoring.
So even SteadiCams didn't really have a solution at that point. So we created this device called the Cube, which was really just using H.264 and Wi-Fi in 2010. And that was really the best technology that was available to us back then. And we used this to stream between two boxes, so you could either stream it to a decoder that could then go on the back of a production monitor or a handheld monitor, or you could even stream it to an iPad. So that led us to continue to push on what other alternatives exist, and we found this technology by a company called Amimon. At that point it was called WHDI, which is a wireless standard that they really designed for the living room to try and eliminate a HDMI cable. So it was designed for short range, but really truly zero delay wireless video transmission, so that you could have an Xbox or something like that and you didn't have a delay from the game controller to the display. And we realized it has real potential, but there was a number of things that made it not suitable for our industry. The first was that they only used HDMI. It was really short range. It didn't have support for metadata or any of these things that we rely on in our industry. So we worked with them, but we took this technology and we adopted this to be more suitable for our industry. We developed the SDI interface for this, added support for metadata, time code, start-stop signals, all of those things. And then also started working with them to increase the range. And that was really a landmark change in the industry.
When I started Paralinx, there was a $25,000 system that went 1,000 feet and a $6,000 system that went about 10 feet. And we entered with a product that went about 300 feet for about $1,000. And we've kind of, since that point, brought wireless video in HD to almost every single film set on every single camera package. It's kind of become gone from a specialty, super high-end product to as important of your camera package as a battery or a tripod.
So as you are finding out we're focusing more on video monitoring on set. We're going to touch a couple of things, but that's where basically what we're going to be. So the custom of interference that we have on set, you have DMX boards. We have Prestons, which we learned that they usually work on the 2.4 gigahertz frequency, but still they're airwaves. We have routers or telecommunications. Some of them are ADs doing the production report or the next day's call sheet, but they're on set. So there could be a router on set on the stage. The studios have wireless. They have internet access. So your Paramount, Sony, you can log in. It's even unprotected, unsecured, but it's still a really powerful devices that they have to get the access to everyone. You have the Scripty. She needs to send her reports or to clients if it's a commercial. Even the stand-ins, they put a dongle and they can surf the web and do their shopping when we're working or we're actually shooting. So the ATs also, there's the colors. There's you can control the cameras at the distance, whether it's a mini or a red camera. So there's the need to have routers on set, but of course they use the 5 gigahertz, and also cell phones, which is a big culprit here because it also uses the 5G band, and also we're working now with the wireless on set. Now we have external causes that also are not under our close control, because if we're on set, we can ask people to turn cell phones off. They might do it reluctantly, but it can be done. But these are the things, if we're shooting next to an airport, aeronautical, weather, rain, water, we're going to learn that water is a big enemy for airwaves or radio frequency. Emergency responder communications, they use the DFS channels. We're also going to learn what is that. Radar, big part of the channels available to us. Military, hospital-related, news, live streaming. Those guys carry these boxes where they put a dongle that can give them access to every carrier, AT&T, Verizon, you name it, and they can stream. And whoever gets the strongest signal, that's the one they use to send very highly compressed. But then you have 4 of them in the 5 gig frequency that they're going to steal the possibility of channels for us to use. And also if we're on location, if we're in a house, well, the house might have a ring, the house might have a modem. Now they're coming out with modems that are 80 megahertz. And you'll see, they said there wouldn't be math, but you will see how the higher the bandwidth, you can send more information faster, but it also takes the space and the chances for other devices to coexist in that space. So we're going to see the video of some of our guests talking about those challenges and pitfalls.
A lot of times what is causing the interruption of video is interference. What causes interference? So there's a few things that can cause interference in your signal for your video system. Number one is lots of devices that are operating in the same band as your device.
Your Ring doorbell system, everything is wireless. People, you know as well as I do, and everybody, it's everywhere.
If you're in a sports stadium or a really packed arena, there's thousands of people that have phones and other devices that are all using 5 gigahertz. So there's so much noise. It's like a crowded bar, and you're trying to hear the person talking to you. If the person's not 1 inch from your ear, then you're not going to be able to understand what they say.
Telemetry that you don't know that's happening in downtown. I've seen that tons of time where it's like, what the hell is that? And it's coming off the bank building, and it's data being moved around, and it's at 2.4, and it's now kind of crushing the Prestons.
One of the worst enemies of this RF signal is the water. We are 60% water. So we are enemies of these signals.
And keep in mind that the human body absorbs 5 gigahertz quite effectively. So if there's a lot of people moving around on set, the signal can't go through them. They'll attenuate that signal.
The problem is that you lose a lot of information and video quality when you're doing that, as well as introduce a significant amount of delay, which can impact your ability to pull focus, operate a camera remotely, or monitor synced dialogue over a headset.
If you were to put multiple devices in the same channel, you're definitely going to have issues with interference.
You could have a device that has channels on it. Those channel 1 might be 5180 to 5220, 40 megahertz channel. However, if something else is turned on in that, the receiving device hears 2 signals that are both on top of each other, and it's like being in a crowded bar. You can't really hear the word. You're hearing the words, but you can't make them out. So to get into a clear channel, you end up having to change channels like on an old television or on a walkie-talkie. What we'll see is if you're in an environment where there's very little or no open space, you will try to jump to another channel, but maybe there is no other channel, or maybe the channel you jump to is right next to another device. The other device hears that new signal, and that device will then start jumping. What can happen is when there's no free space to jump to, that can cause a cascade of no video.
For me, the most important part why sometimes the system fails is just because of operators.
You're doing, these guys are video system, the guys who are using this gear are doing the best they can with the tools that they have, and also doing other jobs.
So on the types of monitoring, we have 2 mainly. One of them is the licensed system, which is what Noodles would have or would be there for. So it's the RF department, and they take care of everything. They're based on licensed channels. So this they apply to the FCC and whatever authorities are to be talked to. So they get the permits and they say, okay, we're a film company, we're going to be in this area, we're going to be shooting from this time to this time, from this day to this day. We need access to a channel. So they get a frequency, they set up their carriers or their devices that will put the video signal on, and they will regulate, they have the power to regulate the strength, but that's because they have already a paid permit to do it. So that's the license, which we won't touch. We're going to focus on what we would call off-the-shelf wireless systems, which all of them work on the unlicensed frequencies. So when you're working on the unlicensed frequencies, you have channels for manual selection, which is the Uni 1 and Uni 3, and then DFS, which is 7 channels. When you were talking about when you're using 40 megahertz of width of the band, these channels are on the DRS frequency. It's Uni 2 and Uni 2 extended. So what is DFS? As Greg mentioned on the video, it stands for Dynamic Frequency Selection. It's for unlicensed devices working on the 5 gigahertz frequency. These devices, when they turn on, they start listening to channels. They will find the channel that has little traffic. They will start operating there. But if there's some sort of interference, if it's like a radar sends a beacon that the devices listen to, and they understand that they have to change channels. These devices, by the way, when they get bumped out by a radar, they know by law that they have to stay out of that channel for a certain amount of time. I believe it's like 30 minutes. Now, for frequency selection, we have the DFS, and we'll let them explain.
DFS, Dynamic Frequency Selection. depends on your point of view. It's people, they love DFS, and people, they don't like so much DFS. But nothing is free in this world. Everything is kind of a trade-off, you know. If you decide to go DFS or you decide to go manual, you decide to go both. So everything is a balance in here.
What DFS is a section that originally and still is set aside for use by emergency, first responders, police, military, and aircraft. And to coexist with those institutions or users, basically the RF device has to follow a certain protocol. So what that protocol is it has to automatically be able to leave, vacate a channel if it is interfering with another device. Because you can't really identify who's the originator of a transmission, if you hear interference at above a certain power in the channel in which you're transmitting, you have to just leave. So there's all kinds of ways that we can operate in there. So what we're always doing is systems that are behaving legally are always listening to the other channels to see, oh, where can I leave, where can I jump to if I hear interference, as well as is there something adjacent to me that's bleeding into my channel.
So the DFS technology that we use allow us to listen first, and then only once the channel is proven to be clear, then we transmit, and that test is run repeatedly. But if we then find a DFS channel that's open, that means you basically have no interference from normal Wi-Fi that's built into your cell phone or anything like that, or from other transmission systems that's used on set, whether it's audio or wireless control for your lights. None of those will be on the DFS channel, so you're pretty much guaranteed of no interference.
What's good about the DFS channels is that because of these protocols, a lot less devices exist in and transmit in these bands. So you have to institute software that's running at the RF level that's saying, okay, we're good, oh, interference, let's jump over here. And this is a whole process that's running all the time. So a lot of the consumer devices that use 5 gigahertz, they only sit in the non-DFS channels, which are 2 channels at the top and bottom of the 5 gigahertz band. The thing that's good about those is that when you exist in those, you can just turn on your device, and as long as it's transmitting in the correct power level and not bleeding across other channels, you can just turn it on. That's what we call broadcasting.
So the way our system works is it'll automatically select the best channel that's available, but you can limit the block of channels that it will select from so that you can get multiple units to operate in a co-located fashion.
Sometimes, because of ignorance or I don't know why, I have been in the set and the people, no, nothing is working. I start looking and they have 10 transmitters. And of course nothing will work. If you have a DFS, you have 4, 5, or depends on the width of the channels available. If you put more than 4 units, they start fighting each other. So some of the units, they will never find a channel where they can stay and transmit. Or when they go in there, they kick out the rest. So for sure, when you turn the system on, they scan, they found a little bit less interference in one, goes in there, the transmission goes for 30 seconds and goes away again. This is because you can never use more than 4 transmitters in the same location, because you don't have more DFS channels. Now, the way to use more than 4 transmitters, it's going to be probably you can use 4 transmitters in a DFS system and another 2, no more than 2, I would say, to be safe, in manual channel selection.
Now, something very important that all these companies that create these products do, at least the ones that they get the proper certification, is that when you do select a channel or when the device lands on a DFS channel, they stay exactly in that channel. So you don't get the bleeding or the skirt, they call it skirt effect, when a device will take, it's supposed to take, like, think of this as a stalled park of your car. If it doesn't park exactly there, it can take another channel, and then there's another device that cannot work. If they have the skirt or the bleeding to the other channels, it's like if you bring out I don't know, like think about those minivans from the A-Team or something like that had super extra tires, and then they're blocking the adjacent parking stalls. So now you're for only one device, you have 3 channels blocked. So there's that one part. Second of all, so besides limiting the amount of devices you can have on set, the other problem that it has, it becomes a headache for the camera operators, which is something that some people don't realize this, and that is that some of these devices transmit at a higher voltage that they're legally allowed to, because they didn't pass any certification. So they are pumping more wattage that they're supposed to. And when I said headache, I said literally a headache, with the possibility of longer term damage on the person. And as you know, usually the transmitter is very close to the head of the camera operator. We're going to have a little more talk about those things.
The 5 gigahertz band and the 2.4 gigahertz band are unlicensed parts of the RF spectrum. What that means is that if you buy a device which is certified for operation in that part of the spectrum, you don't need any sort of special license or permit to operate it. It's like a phone or a Wi-Fi router in your home. You can turn on the device and it will work. What that means is that the device already goes through a rigorous testing and certification process so that it adheres to the rules of the unlicensed band. Those rules include the type of transmission that you're generating, the amount of output power that your system delivers, as well as the cleanliness of the channels in which it is existing. So there's X number of channels in the band. If you're transmitting on one of the channels, you have to be clear of all the other channels. The idea behind that is that you want to be able to coexist with many other devices, because you do not get that channel to yourself. If you wanted that, you would have to pay for a licensed channel.
So this is one of the reasons why we struggle so much with some people just gladly accepting these cheap knockoff products, because there's just so many obvious mistakes that they make, and there's so many rules and even laws that they break. It makes it hard for us to compete with them. We have to go through all kinds of certification, and we start with a product that costs us a lot more. These guys buy chips from the black market in China. That's illegal chips. They don't have the right software on it. They pretend to have certification, but they don't, and we know they don't. But our hands are tied. We can do nothing about it. So it's kind of painful to see that the industry accepts something like this, that is illegal, it's unsafe, it's insecure, it doesn't protect your content. But just because it's a little bit cheaper, people use it. Now, in some cases, they might say, well, it works just as well, or they might even say it works better. And unfortunately, that is true, because these guys are not abiding by the rules. So the products might work better because they don't have a return channel. They always broadcast, so they don't have to wait for confirmation for a key exchange or to really confirm that the DFS channel is open. Or in some cases, we've measured that their power output is illegally high. So they're building illegal, unsafe, insecure products.
I would say there's 2 kind of main types of improperly operated devices. Number one is a device that's illegally transmitting at a higher output power. So this is a system that's pumping higher amount of RF to try to go further, as well as bleeding that transmission across multiple channels. So there's only 11 channels in 5 gigahertz. You know, if you're taking up 3 of them, you know, you might even be taking up 5 of them. There's only room for one or other device to coexist, really. those kind of systems can really cause problems. Other types of interference from improperly designed devices are electromagnetic interference, which is what we call unintentional transmission. So if something has electricity going through it at a certain frequency and it has a bad cable in it, that cable can actually act as an amplifying antenna, which can spread noise across the whole spectrum.
Just be aware that just because you have this device doesn't mean you're free from, if you're interfering for some reason and there's a licensed holder, or they can ask you to shut that off. That's just the way it works. If you're interfering, and maybe you don't even know you're interfering, but if there's a complaint filed, then you've got another issue.
But if you have a system that allows you to manually select a specific channel, chances are that this is illegal. If you select a channel in the DFS frequency with a knob and it just stays on that channel, that is categorically illegal. It's not supposed to do that. You're interfering with the radars used by the FCC and FAA in airplanes, in airports, and even the weather radar used by the weather bureaus, the TV stations. It's giving you the weather.
When we go on projects around San Francisco, anywhere the military is, Edwards, all that, I have to get permission to use pre-selected channels because they have all sorts of data testing going on, drones, all the military stuff that's going on in China Lake when we're shooting out there. You just can't turn it on.
Trying to get the maximum output power of the transmitter is what everybody does, but this is clearly limited. It's governed by all kinds of health standards, FCC, CE. Well, everybody has a standard on how much you're supposed to output on the transmit side. And this is because the human body absorbs that 5 gigahertz frequency. So if we output too much, it's pretty much like putting your head in a microwave, which is another reason why you should stick to the proper certified products and not use anything. We've heard some interesting stories about people's dental fillings heating up and all kinds of weird.
So the tool that we work with is radio frequency. So to understand a little more about radio frequency, we need to understand that it's measured in hertz. And a hertz is one cycle in 1 second. So you get the math when you have 1,000 hertz, it's 1 kilohertz. You have 1,000,000, it's a mega, and you have 1,000,000,000, and that's a gigahertz. And this is per second. This is 1,000,000,000 cycles per second. So we're talking on the 5 gigahertz band, which is, just imagine. So the higher the bandwidth, or the frequency in gigahertz, the more data you can carry. On the contrary, if you go with lower devices on the spectrum, does anybody remember 900 megahertz phones? At one point was the cat's meow. Then where were they? Then it all become in the 2 gigahertz frequency, 2.4 to 2.8, and now we're working in the 5 gigahertz unlicensed band. More things that we can put together are in radio frequency and measure in these hertz. So you can have your white light, your visible light, your X-rays, your microwave, which is another type of radio frequency at a very high rate, UHF, VHF. So there are way many more things that you can imagine that all of them land on the chart on a different section. So the unlicensed frequency, as I mentioned, you have 900, 2.4, and 5 gigahertz from 5.1 to roughly 5.8. You don't need a permission to operate a device if it has properly approved by the governing authorities. You can it's strictly defined with RF specifications. It has the output levels. They have a cap legally, and they also require the channel management that we spoke about on the video. Here we have the chart, the 2.4. So it's what we were saying. You were more limited on the amount of channels that you could play with. If we go to the 5 gigahertz chart, then you have more units or more channels to work with. So the bandwidth that the data that can be transmitted, it can be on the 20 megahertz, 40 megahertz, 80, or 160. And it's direct math. You have a certain number of channels, half at double the bandwidth and half at double the bandwidth. Right now, most of the systems are using 40 megahertz. So you got in Uni 1, you have 2, and Uni 3, you have 2. These are the manual select channels that are out there. And then on Uni 2 and Uni 2 Extended, you have 7 channels that can be used. So then you're now limited to just these 7 channels. So, but now we're working with 40 megahertz. So there's even less opportunities to have devices. So assuming that all the transmitters are having a perfectly clean signal that lands on that channel at 40 megahertz, that's what on the video they were talking about. You can have 7 on the DFS, assuming this one can be used, and then only 4 on the manual selection. So only 11 channels at 40 megahertz are what you can have on set. And this is, as we started the conversation, this is shared by routers, by even Prestons. Even if they're not in that frequency, they move in cycles. So all this can eventually alter the output of what we have in video. Ideally, you would have a channel in between open, so if there's a problem with bleeding, you don't get an interference with another device. But this was the big eye opener for us. Now, if you were talking about sending a lot of data far, then the 20 megahertz band would get you farther with a little less quality. So that's a resource that some manufacturers use to be able to get even farther where we are. This other chart, now shows as well which are the DFS channels and the ones that are manual selection. Just in case anybody cares, UNI stands for Unlicensed National Information Structure, and that's what UNI stands for. Now, just like a DP in the old days would not show up to set without a light meter, or like a Jenny Up would have a voltmeter, or we need some DIT, maybe a waveform monitor, or now they use false color. But there's always a tool that can help be more objective about what's going on with the environment or the elements that we use to do our job. So there's a resource for us, which is a spectrum analyzer. These toys can go anywhere from $300 to $30,000, and they become a really, really useful tool when we're on the set. Now the newer firmware of Dream by ChilipepperLabs and Teradek, they come with a spectrum analyzer that can save our jobs.
Our devices have, on the receive side, a spectrum analyzer built in, and it can show you on the display, on the LCD display, it will show you these are all the channels, and this is the amount of energy that's in each channel. So that will equate to the amount of interference. So then you can see which channels are going to have the lowest interference.
And just walk around, talk to the lighting guys. Lighting guys are also using the DMX, frequencies and to control a lot of lights. Special effects guys are. And basically, when we come on set, we kind of make the rounds and ask everybody what they're using, and so that we don't interfere.
And we don't want to be the one that interferes with other critical systems on set, like a follow focus or audio or anything like that.
We also carry spectrum analyzers, so we can look at everything, right from the wireless mics to the Wi-Fi routers to everything. So now you can see what's happening in the environment and why things are breaking up, or what's happening, or people are having issues.
So first of all, pay attention to the little graphical spectrum analyzer that's now included with our new software, because that will help you just see where to position units, and you can see the other units on there. And so again, you can select a block of frequencies and tell it to operate in that block, and by segmenting it that way, you can prevent the one unit from interfering with another unit.
This tool is a spectrum analyzer, which we use all the time. This allows you to look at, it's -80. This is a noise floor. Our frequency, center frequency is 23761. This tool is excellent for when we're working with the drones. We do a lot of that where the production will call us in to say, hey, Noodles, can you come and look at this area where we want to fly? And we say, absolutely, let's look at, we'll do a little scout. Does a lot. We also have these very inexpensive spectrum analyzers that everybody can buy, and pretty handy to have for $300, and it'll give you an idea of what's happening around your surrounding area. So if we want to put that carrier up, and we'll take a look, see what happens here. So you can see the resolution here and the resolution here. So we'll add another carrier. There we go. So this lets us know that we have great separation. Nothing's touching or interfering. We've got the channels selected in the proper spacing. Really important, so that you're not interfering on top of each other. That's a protocol that should be looked at. And that way you're not going, well, why is this not working? Well, you know what? The guy next door is using the same frequency, and that's why it's not working. And that happens a lot. I've seen it.
Now, another very important thing when we're doing our job is encryption. When you pair up your transmitter with your receiver, you are telling both are agreeing on a password or a code, a key. So when the transmitter sends the signal scrambled, the receiver knows that which transmitter is coming from, and then decodes it and then spits out video. So that seems all nice and dandy, but there's some products that are out there that they have a knob, and they have selected channels. So it only takes to pair them up just to land on the same channel as you have on the transmitter, and that seems to be very practical, unless you are shooting a very delicate scene, whether it's I don't know, commercial for a soda company that thinks they're having the next bestest drink ever, and they make you sign NDAs on set, etc., etc. If you're using this system, somebody's out there with one of these devices, these receivers. It's like they can actually see what you're shooting. Or if it's a delicate scene, the actor or actress, they're nude, nobody can watch but the director, the DP, maybe hair, makeup, scripty, and that's all they want. Some people, sometimes I've been on sets where you're in a studio, big studio, and then just walking around with their receiver and changing channels to see, let's see what's on TV and who's shooting what. And unfortunately, there's a lot of these devices around, which, as we said, they bone everybody when it comes to being able to coexist with the frequencies out there. Another big important component on wireless transmission is antennas. So an antenna, what it does, it's very simple. You have the device. The device outputs a video. The device receives a video signal. It encodes it, converts it in electricity. The antenna excites the electrons excited in the antenna, and that comes out as a wave. Then on the other end, you have another antenna that will receive that. The device will decode it, and then you have your video out there. It's, there's transmission, a message, and it gets decoded. So you have an antenna. It's pretty much just a rod inside of the plastic. There's maybe some attention to some materials, but in reality, it's not that big a technology on antennas. But they are measured in dB, in decibels, and something that you can do is there's certain reciprocity with antennas. If you have on the transmitter, you have a 5 dB antenna and a 10 dB antenna. It's the same as if you have an 8 dB antenna and an 8 dB antenna. So if you have 15 dBs between both antennas, then an antenna can help you send a cleaner, farther or signal, or on the transmitter. Or if it's in receiver, it can allow you to listen to that transmission easier. So that's an important part. So in antennas, we have three types of antennas. The omnidirectional. These omnidirectional, they radiate the radio power, the radio wave uniformly in all directions, but only in one plane. The radiated power decreases with elevation angle above or below the plane. So it's horizontally, but nothing above or below the donut. It also drops to 0 on the very center of it, just like a donut. The whole doesn't taste good. Radiation pattern is often described as a donut shaped, as we said, and it radiates equally in all horizontal directions. The panels. These panels are in both the previous antenna, the omnidirectional, and the panels can coexist. That, as a matter of fact, the panels used on the receiver end, and it has 2 or more antennas grouped in a panel to capture one signal. It captures in a more directional way, but they have 19 or 23 degrees. So it's like having a telephoto lens. It's more dedicated, and you need to make sure you are in the path of the antenna to have a signal. If you're not, then it can work against you. It provides more focus to coverage than a single omni antenna, and can be passive or active, which is it allows to be electronically amplified. So these antennas, these ones have 5, okay? And here you can see the distribution of the antennas. So you have vertical, horizontal, and diagonal. So this way, they are covering all the possible angles how a wave can come, the wave from the transmitter are. But you need to really be focused on your transmitter, or if not, you could be just doing a disservice. The antenna has a back. What will do is it will project whatever was getting into it. It will bounce it back. So it will allow that the little antennas that are behind this panel to catch the signal. So they're very useful, but for every situation that we have, there's a proper tool. Sometimes when you're on short range, sometimes a panel will not be the best thing you can do. Just have the receiver, put your vertical antennas, and you're off to the races there. The third type of antenna is the unidirectional antenna that we have here on the screen, and usually it's used by drones, and they broadcast in a same one direction, which in this case will be down. So they can monitor where the drone is shooting, and they're small and they're lightweight. Now, talking about antennas, let's have our friends talk about it.
Picture a sine wave. It goes like this, right? When an omnidirectional antenna is transmitting, it has a pattern that comes out of it in an omnidirectional manner. It looks like a donut, right? The donut is comprising 1 million sine waves that goes all the way around, kind of like an atom or a Brillo pad that has 1 million weaves that are going out in a linear, polarized fashion. those waves go out like this in an omnidirectional way. But the best way to capture them is to receive them with your omnidirectional receiver antennas directly line of sight like this. Now, radio waves can bounce off of your environment, and so you may have just as good of a performance by having your receiver antennas mounted in a different pattern, but the best chance of getting a really good signal is to have it lined up, line of sight, and flat to each other like this.
When you use a system like Bolt, we offer two different choices for the antennas on the receiver. You use the 4 omnidirectional antennas, or you can use an antenna array, a panel antenna. So the difference is the panel antenna is, it's like a telephoto lens. It really zooms in on a much narrower part of the scene, whereas the little rubber duckies are omnidirectional. So they receive energy from a full 360 circle around you. So any interference that might be originating from behind you or next to you will also be incorporated.
One of the benefits of a panel antenna is that it's very directionally focused with higher gain receiving antennas. So you can really aim it at your subject, you know, so if you can see a transmitter or you can see your environment, you can kind of focus where you're trying to hear the transmission.
The panel antenna is like blinders. It really eliminates all sources of interference from the sides and from the back, and it really focuses the listening only from a specific direction. So this is obviously, it's really good whenever there's known sources of interference, or if you need that extra little bit of range. You can use the panel antenna for that too. Because it now eliminates all this interference, you can increase the gain on the receiver without running the risk of amplifying the noise, because you're eliminating a lot of the noise, right? So with the same amount of transmit energy from the transmitter, you can basically boost the sensitivity of the receiver by using that panel antenna.
Most of the array antennas are between 23 and 19 degree, so it's really narrow. So that antenna needs to point. But as close as you are to the antenna is even narrow, because this is like this, it's a wedge. So if you're far away, it's okay, because it would be in some place in the angle. But if you're really close, it's a moment when the edge, the wedge is really narrow. So you must be right there pointing to the array antenna. So in the close situations, less than 50 feet, 100 feet, you don't need to use array antennas.
Some applications, the panel antenna is not going to be better. What happens in wireless is when you're too close, now there might be so much energy that you're actually overwhelming the amplifiers on the receive side. And that could be detrimental, because you can't fit the whole signal in. So you really need some attenuation. You need some distance or smaller antennas. That could be one scenario. The other scenario is sometimes when you're in a small environment, let's say a smaller sound stage or an office setting like this, the wireless signals actually bounce from the walls and the ceiling. And this can give you the benefit. Sometimes multipath could be detrimental, but in some cases it could be beneficial, because you might actually block the direct signal, the direct line of sight, but then you get a reflected signal coming from elsewhere. And with the MIMO technology, the receiver is smart enough to be able to reconstruct and use the signal, and it can choose between which version of the signal to use, or it can actually benefit from using both at the same time. So when you use the panel antenna, you're eliminating any of these reflected signals because you're now so focused. So that it might not be beneficial. So you should really try both sometimes.
Antennas, we have lots of different antennas to do a lot of different things.
The most important here is the difference you have between the signal itself and the noise. When you put an amplifier in the middle, you amplify both. You amplify the signal and you amplify the noise.
Sometimes it's not about all the power. Sometimes if you increase the power and you don't know how to look at it properly, you're defeating the purpose.
It won't give you additional range beyond the prescribed range of your device. You know, say you have a 3,000 foot device, you're not going to get 10,000 feet. But what you will find is that if you're operating it appropriately, you'll have a more robust connection up to the maximum range of the device.
We need to learn to use our tools. In some cases, in some situations, all vertical antennas will do the trick. This is line of sight. You will not want to engage a conversation that you care to talk to somebody like this. You'll be totally frontal, and that's part of the body language that also transmitters and receivers require, and that's something that would help us. But a big problem that we have, and what they suggested was putting the antennas slightly open, but not only slightly open in a V, not a very wide V, but a slightly, but then also separating them a little bit. So if you can see, there is always a V factor on both angles wherever you are. So if you see there, well, there they are, depending the direction, the distance, but you can try and experiment and see what works better for you. Another thing that is very important to have, with antennas, we have that directionability, the gain that we're saying that it could be boosted or not, or the bandwidth where they operate better. For RF attenuation, this is something that is inevitable. As long as we're shooting in the conditions we shoot, there is a decrease of strength as the distance goes. If you have straight line of sight, the strength of anything will decrease. If anybody here shoots, you understand the inverse law of the lighting. The farther the subject, the less light will get, the farther you are. Vaguely described. Same with radio waves. So that we have attenuators. These are elements that will diminish the output of the transmitter, and therefore the use of the benefit of that video signal. So we have some objects that they have a factor depending, as you can see on the chart, the 2.4, which is the left numbers, are lower than the 5 gigahertz. The 5 gigahertz chart, because we said when they have a shorter bandwidth, they tend to go farther. They cross through physical things a little bit easier than the higher band. Now, in this live, we have heard a couple times on set, you can pick price, you can pick speed, or you can pick quality. Well, somehow video transmissions, in their own way, they have their own little saying. And you can only pick two, which is latency, resolution, and distance. So you have these three elements that you can pay a price. If you want to have more distance and you need the resolution, you could be risking latency. And this is something you don't want to play with. If there's something you don't want to play with, especially focus pullers, is latency, because you want to be able to see immediately what happens, how it happens. Also, one more thing that could be useful as a focus puller is the resolution. That's how you judge the focus. But maybe distance, because you tend to be closer, not as close as in the old days, but closer to the camera. So in reality, you are not. You don't need that distance, so that could be the coin that you're willing to lose. And we're coming towards the end. We have the best practices according to our experts.
If you have two receivers co-located and they're out of phase, this one might turn on its transmitter during the blanking period of its video, overwhelming this receiver. So the way to remedy this is if you have to have two receivers co-located, which happens quite often on set, what you want to do is separate them as far as you reasonably can physically, then separate the channels that you operate them on as far as you can. You can, on our devices, you can limit the range of channels that they use.
The same thing can be said for the transmitter side. So if you're able to separate your transmitters in a really bad environment, that can be one of the little things that helps.
And then also, if it is practical, try to gen lock the cameras, the video sources, so that the blanking periods coincide, which means the two transmitters will always be in sync and the receivers will turn off when the back channel transmits. So then they won't interfere with each other.
Another thing that helps is antenna positioning. So if you've got your antennas all down or crossed or underneath a camera, surrounded by people, all those things can cause interference or diminished signal strength.
In the research we discovered when you put your receivers in the back of the monitor, you kill around 10-15% of the signal. On top of that, if is a lot of people around you, which is normal in any shoot environment or set, is the focus puller, and you can see 10 people around the focus puller trying to look at the same monitor. And those people, they're eating a RF signal.
And keep in mind that the human body absorbs 5 gigahertz quite effectively. So if there's a lot of people moving around on set, the signal can't go through them. They'll attenuate that signal. So if you just raise it slightly above the average height on set, you're going to really improve your wireless performance quite a lot.
If you look at sound guys, they have been dealing with wireless for generations. And if you look at them, the antennas of the receivers, they're really up there. Probably at, I would say, 7 or more than 7, 8, 9 feet up. Same way for us. You have to put your receivers as high as you can. Receiver at this height, at height of the table, is a mistake. Transmitter needs to be as high as you can.
And try and have them clear the camera body and even the camera operator by as much as possible. So in an ideal world, you'll have the transmitter mounted on the top handle of the camera. That's hopefully, say, 6.5 feet up. And the receiver, mount that on a light stand, a C-stand, and just raise that so that you can see there's a line of sight in between the transmitter and the receiver.
So when you put your transmitters on top of the camera, the antennas pointing up. Antennas horizontal is a mistake too.
One thing you never really want to do is have your antennas mounted horizontally, because now, it doesn't really transmit this way. It has a donut that's going like this. So half of your signal is going into the concrete and scattering, but not scattering very far. And the other half is going up into the sky and going out into outer space.
So if you have the 2 antennas on your transmitter and the 4 antennas on your receiver, and this is the ideal configuration. Both of them are now on the same vertical plane. But let's say you can elevate this quite high. So now you do want to tilt both of them just slightly to try and get them back on that perpendicular plane where they transmit the energy. But don't go overboard and don't open these up. Keep them the same way.
Managing those little things like making sure antennas are up and above someone's head can really make a huge difference, even if it's an invisible thing that you can't really tell. A lot of times the same thing goes for the receiver and making sure it's pointed at the transmitter.
So summarizing, they gave us some very important points. When the systems when we're prepping the camera, make sure that all the antennas work. You could have one of the receivers with the spectrum analyzer on and put antenna by antenna on the transmitter and see if something spikes. That's a good first thing when you're prepping your camera. As they mentioned, the physicality of an antenna, they're fairly resistant, but you cannot really tell if something's broken in there. Don't over-tighten your screws. That can damage your equipment. There's little locking devices that you can put on them, and that it's safer. Line of sight, repeated ad infinitum. Always be able to see the transmitter and the receiver. There's parallel with the antennas. Do not go in these crazy configurations or putting the antennas in different ways. Remember, they are omnidirectional. They only scatter the signal horizontally. So you need to be on the same plane so both the receiver and the transmitter communicate. So your video shows up. Limit the amount of physical obstacles, redundant for line of sight. Operate devices above heads, so there's line of sight. The transmitter antenna position, height, direction, and orientation. You can try that V that they mentioned to us. So they're slightly separated on both situations. Receiver antennas or panel in position, always pointing at the transmitter. BNC cables, and this is for the DITs. This is something that sometimes happens on set, and it really bugs everybody. Sometimes some cables are not shielded properly, and when you have your AD yelling or trying to whisper, they usually come next to the DIT. And when they transmit and the DIT has one of the components, one of the BNC components, and it's not shielded, the transmission from the radio is going to come just in the whole line of communication, and you can have the best systems around. You can have Noodles there, but if one of your cables become an antenna, that's not good. Limit the use of barrels, especially T-splitters. That's very important. If you need to make a long run, if it's possible, put a DA. Freak Show, you can get really decent products at a very decent price. AJA, they have also reclocking devices that you can put on a Anton Bauer battery if you have a long run. Technically, they say that HD runs no more longer than 180 feet of good cable, assuming nobody has run over that cable. You can choose and disable certain channels. You can scatter what channels are being used by each one of the devices. You can manually select some of the DFS channels, and if they're a couple, they can jump from DFS to manual selective channels, depending on the system that you're working with. Try to separate transmitters and or receivers. Always remember that receivers somehow are a transmitter as well, because they are in constant communication with the transmitter. So you want to try to keep them as separate as possible. So leave room from on the camera on the transmitters, and also on the Video Village side on the receivers. Last not least, very important, familiarize yourself with the spectrum analyzer when you prep. Get there early. Start, pop a battery on one of those receivers that they have, and start seeing what's going on. Walk around. If you're on a big facility like Panavision, Keslo here, you can see that the other people are prepping. They have transmitters, and see how the device reacts to the proximity to those transmitters. When you're prepping, make sure you know what kind of cables you need to pair devices. So on set, sometimes you can use a computer to pair them up. Sometimes it has to be over the airwaves. But if you're in a studio, Sony, Paramount, whatever, then you run the danger of not being able to do it as easily, because the transmitter has to be on pairing mode. But anyways, sometimes it's easier, better just to do it over the computer. Always have a clip nearby. With the Teradek systems, you need to reset, or you need to put the transmitter on pairing mode. And sometimes it sucks not to have a paper clip. As vain as that, a 5-cent piece, it's wrecking a $10,000 system, and we've seen that ad infinitum on many other things. Keep checking the panel orientation to the transmitter. Sometimes the action happens over there. Nobody's paying attention, and the panel is still pointing at the previous set. So you have to stay on. And sometimes when you have drive-bys and you manage to put the transmitter on top of the vehicle and Video Village is on the ground, well, you need somebody to be kind of following that based on the conversation we had about the directionality of your panel. Thank you, guys. I hope there was at least one thing that you guys learned. If you guys learned something new, even one thing, all right, I would like you to consider joining the Digital Cinema Society. This is a labor of love, all right? Nobody's making a penny. You guys didn't have to pay a penny to come here, all right? A lot of time was put into having this program, and this is what the Digital Cinema Society does. So it's for the benefit of everybody. It's agnostic. We don't favor anybody. It's just about learning how to make our lives easier or to keep employed. That could be the bottom line. You know, they talk about lenses. They have seminars about lighting, cameras. So it's a great group of people to be here. So thank you so much.
Thank you.